For the development of the ears, we have to learn or focus on the picture showing the lateral aspect of an embryo. It is showing three types of placard: the nasal placard, the optic placard, and the otic placard. This otic placard is the future ear, and initially, as you can see, is located in the region of the future neck. It has to be shifted in the head region against the lateral aspect of the eyes later on, when there will be the further growth of an embryo. So let's see how your ears are gonna develop. As you can see, another picture that is showing the sagittal cut section of an embryo. Here what we see this blue color ectoderm. This yellow color tube is the gut tube, or here primitive pharynx we can label, and we see the neural tube. The mesoderm is being removed for simplicity. So concentrate on the neural tube. It is showing three dilatations: the prosencephalon, the mesencephalon, and the rhomencephalon. Why we have mentioned? Because against this rhomencephalon, bilaterally, the ectoderm is supposed to be thickened to form the otic placards bilaterally, right? So this is the region that give rise to the development of the ear, especially internal ear. So it's the internal ear that is going to be developed first. Okay, let's see what happens. Now this picture of an embryo, which is just like a tube, is showing on its lateral aspect, if you concentrate, the otic placards, and they are supposed to be invaginated interior or towards inside to form the otic pits bilaterally. Now see another picture. Now from the inner aspect, you see there is a otic pit formation. So concentrate. Now have a look on another picture. Yes, that otic pit is supposed to be transformed into an otic vesicle ball-like structure called as otocyst or auditory vesicle, right? Okay, this picture is showing you that how otic vesicle is developed by elongated the distal end, and we can see proximally it should be detached from the surface ectoderm finally. Okay, now there is a transverse view to make you clear that this is the outer aspect of an embryo, so ectoderm, and this whole structure is inside showing the mesenchyme. This is the neural tube or rhomencephalon area, and this is the gut. Now we can see the invaginated otic vesicles being attached still to the surface ectoderm through the otic stalk. Now here, though the color is changed, but they are showing you the formation of bilateral otic vesicles. Now see how it develops into an internal ear. That complete rim present initially in this previous picture, concentrate, it has to be divided into two parts: the ventral component and the dorsal component. The ventral component will transform into the saccule of the internal ear, and the dorsal component will be transformed into the utricle of the internal ear. Now you can see this is saccule. It will give rise to a tubular outpocketing that will elongate and take almost 2.5 turns or 2.75 turns within the outside mesenchyme. And now the leftover portion that connects the cochlear duct with that of the saccule will be the ductus reunions. Now you can see that the utricle is still there and how it is going to form its respected structures. Let's see that utricle now give rise to outpocketing like the fan blades, I would say, and of course there would be the third outpocketing. They will grow and enlarge, and finally their central area will fuse with each other with on both sides. Let's see how it happens. Yes, the central area of each semicircular canal are fused, and what happens? This will be dislodged or will be dissolved, and we will have just these semicircular ducts on both in both ears. Let's see. So this is how you can see that the middle central fuse part is dissolved, and we now have just like a steering of a car. These semi-circular, I would say, ducts, they are going to open into the utricle through three dilatations called as ampullaris, and the other end, which is not dilated, is being fused with the two tubes and directly opens into the utricle. Let's have another picture. Here you can well see, let me enlarge it. There are three semicircular canals. They will be showing on the three ends the three dilated openings, and on two ends non-dilated portion called as ampullaris, and in this way they have to communicate with that of the utricle, so they form the three semicircular canal. This is anterior or superior, this is posterior, and this is lateral. Now in this picture you can well observe these dilated ends called as crus ampullaris, and they contain inside the sensory organs, the crista ampullaris, and the saccule will also be having the sensory organ called as the macula of this saccule, right? So we will also be having that utricle inside should be showing the macula of the utricle. So these are the names of the sensory receptors organ inside these internal ear, and let me revise. There lies in the semicircular canal the crista ampullaris, and within the utricle and saccule there would be the macula utricle and macula saccule. And you can see in the purple there lies a duct called as endolymphatic duct and its sac that also originates from the utricle. Okay, now here you can see the coiled cochlear duct. So this whole apparatus is making the membranous labyrinth, and this in its inner aspect carries the endolymph. Okay, now this picture is let me show you in a proper size. Now this darker stain inside is the membranous labyrinth, and the outer skin color demarcation is showing the mesenchyme that will be transformed into the cartilaginous part and finally into the bone, so converting this outer covering as a osseous labyrinth. As we know, internal ear has got two parts, the inner membranous labyrinth and the outer bony labyrinth, as you can see. So they are forming the semicircular canal around the semicircular ducts, and they are creating a portion vestibule carrying the utricle and saccule and the cochlear shell around the cochlear duct, and this is the endolymphatic duct. Okay, now see what happens next. Yes, now we have to concentrate after the formation of the inner ear that how the semicircular canal are towards the middle ear cavity. This is the anterior, I would say, wall. This is the posterior wall of it, right? Okay, now see what next. Yes, this is the one side of an embryo being cut to show you that was the pharynx. So the inner merged portion was the membranous labyrinth, and this outer shade is showing the bony cartilaginous labyrinth, and you can see that it has to be develop communication with that of the pharynx, through which structure we will see later on. Okay, as we know that this whole ear apparatus should be inside the skull, within the petrous part of the temporal bone bilaterally. This is the area called as petrous part of temporal bone. So here we could be having the external acoustic meatus, and on inner aspect we have got the inner acoustic meatus. Let's see how it is placed. Now for simplicity, the petrous part of temporal bone is shown as a transparent bone, and we can see the location of the structures of the membranous labyrinth, and this is the foramen magnum, that is the other sided structure of the coils of cochlea. Now again schematically you would be learning that if we cut the cochlear duct, how it will be appearing. So that is a cochlear duct marginated by the cells, and on its outer aspect we have got the osseous or cartilaginous shell made up of mesenchyme, and that cartilaginous shell will be coalescing to form two compartments. The one is scala vestibuli above the scala media or cochlear duct, and below this cochlear duct or scala media there lies the scala tympani. You can see the appearance of various vacuoles that will finally dislodge, and a complete clear scala vestibuli and scala tympani will be formed. And on its medial aspect we have got the central core of a bony structure called as modulus, that is made up of a spongy bone. It will be carrying inside a spiral ganglion, and we can see its nerve fibers forming the auditory nerves or auditory portion of the eighth cranial nerve, and the area that is extending from the modulus up to the basilar membrane just below the organ of Corti. This bony shelf-like structure coming from the module is called as osseous spiral lamina, and above its periosteum bulges to form the limbus spiralis, right? And what about the organ of Corti? It consists of various cells, inner and outer hair cells, and we can see other varieties of the. Okay, we were talking about the organ of Corti, which lies within the scala media. We see the vestibular membrane on its uh, top area, and the basilar membrane where its cells rest. On its very lateral aspect, we see an area that is showing the stria vascularis that is supposed to secrete endolymph within this scala media, right? And there lies the spiral ligament that attaches your this base of this scala media to the bony shell. So now we know that scala media has got an apex attached to the modulus just near to it, and a base having stria vascularis being attached to the lateral wall through spiral ligament. Now see how the spiral ganglion is going to develop. These are a structure being detached from the aortic vesicle, comes nearby the cochlear duct. Now see, they should be arranged in a spiral fashion to form the spiral ganglion. Here you can see there are so many nerve fibers that have developed and being attached with this cochlear duct. So let's see from there where they get originated. Now you can see the transverse section of again an embryo, the ectoderm. This is the rhombencephalon area. This is the gut area, and these are of course the aortic vesicle. So the cells from the aortic vesicle, they are specialized, and of course the neural crest cells, they are specialized and take part in the formation of spiral ganglion. Let's see how. Yes, you can see they are arranged as such to form two portions of the vestibulocochlear nerve. Now you can see that this single vesicle is going to be divided into the ventral and dorsal component we already discussed. Now here you can see there is a picture showing one of the neuron, which is of course bipolar, present here, and on its one end it is attached with that of the organ of Corti, and on the other end it will definitely transform into the cochlear portion of the eighth cranial nerve. Now see how these two vestibular and cochlear portions combine to form a single nerve. From this saculian this utricle and semicircular ducts. The nerves are coming to form the vestibular portion of the cranial nerve. These are the superior and inferior vestibular ganglia. And here you can see the cochlear segment of the eighth cranial nerve. Combinedly, they are forming a single vestibulocochlear nerve. Now you can see specialized area inside these sacule and utricle. Okay, the paralymphatic duct is present, which takes perilymph from the scala vestibuli and scala tympani, and they should be draining into the subarachnoid space, right? So that is why, as it contains the CSF in it. So as we can see in the picture, this is a subarachnoid space and carrying the CSF. So you would say the composition of the perilymphatic fluid and CSF is same, right? Okay. Okay, now this picture is showing you the enlarged view of the specialized sensory area carrying various cells, and you can see here the utricle, and we could be having a look on the macula. Let's see the various hair cells are showing. Now here we see the macula having the hair cells and stereocilia over it and the kinocilium. Now you can see the otolith organ or otolithic membrane present over the macula of these sensory organs, and how they are placed perpendicular or right angle to each other. This is how, when our head moves, the internal organs of the inner ear senses the position of our body. Now see the cut section showing the scala vestibuli, scala tympani, and scala media. Here you can see the organ of Corti, and this is tria vascularis because it's lateral wall, and this is the modulus. This is showing you that this organ of Corti is present throughout the floor area of the scala media, like stairs in a room. Now you can see a closer look of it, that these whole are the cells of the organ of Corti. You should be imagining that this is not present just as one piece, rather it is present throughout the floor of the scala media, I would say. So imagine a room with the floor being covered with these organ of Corti throughout its whole length. You can see various cells, and this is the pictorial membrane over it, and these are the outer inner hair cells, the inner tunnel to make this the organ of Corti. So a picture comes in front of you. You must remember the pharyngeal arches, pouches, and clefts, and the membrane. So that is on the outer side, the blue line is showing us various pharyngeal clefts. So this is the first cleft. Now concentrate that it should give rise to your portion of the external ear, the external acoustic meatus, if you can recall. The base of it is going to give rise the meatal plug, which later on will be dislodged. And when this uh, artery area, this metal plug will be dislodged, it will finally contribute in the. Now the area of this cleft, this epithelial lining will now concentrate that this pharyngeal cleft, the portion of the external caustic meatus, its epithelium will take part in the formation of the outer cutaneous layer of the tympanic membrane, that is being formed by the first pharyngeal membrane. From lateral aspect, the ectoderm is taking part, and from the medial aspect, the innermost layer, the mucosal layer of the tympanic membrane, is contributed through the first pharyngeal pouch, right? An intermediate or fibrous zone is formed by the mesenchyme of the first pharyngeal arch. Now again concentrate that this first pouch is going to form the epitympanic recess that will be converted into primitive tympanic cavity or middle ear, and then it also gave rise to the auditory tube. if you can recall the pharyngeal apparatus. Now see what next. Here we can see that the lateral aspect of the embryo in the area or vicinity of the first and second pharyngeal arches around the first pharyngeal cleft. They would be giving rise to six swellings or six helix, which we called as auricular helix. They are numbered as 1, 2, 3, 4, 5, and 6. So, 6 on each side of the body of the embryo. They will be transformed into a very complicated manner that the number 1 auricular helic will develop into tragus, and rest of them, those are developed from the second pharyngeal arch, will produce the helix, the antihelix, the kimba, all the structures, the antitragus. So keep in mind how the external